Okay, so today what we're going to talk about is everything that you need to know about electricity. Before we start talking about electricity itself, we need to know some background information. And the most important piece of background information that we need to know is something about positive and negative charges. A positive charge does not mean that it's good, and a negative charge does not mean that it's bad. All it's referring to is that something that's positive charged means it has more protons than electrons. If you remember talking about an atom has three main parts to it. You have protons, neutrons, and electrons. Your protons are positively charged, your electrons are negatively charged, and neutrons are neutral charged. Next year in 8th grade, you're going to talk some more about that, so I wouldn't stress out so much about that right now. So after that, those charges, electricity is basically a flow of electrons, which are negative charged. In order for you to have electric current, you need to have continuous flow. Static electricity will not work as electricity. It's not going to make your TV play or your flat iron turn on or your PlayStation go. It's a one-time thing, like lightning is a one-time flow of energy. You need continuous flow or an electric current. If you look at the picture down here, you'll see electricity is a flow of electrons around a circuit. In a little bit, we're going to talk about what a circuit is. But you'll notice these electrons here are flowing like this. They flow out of the battery to the lamp or the light bulb and then on out. So every piece of electricity, yes, there's wires, there's electricity flowing in them and out of them. An amp is the standard unit of measuring current. It's the amount of charge that flows past a given point per unit time. So it's kind of like if you're at the finish line in an hour, how many charges, how many electrons, how many people, how many cars go by you in an hour. Okay? Amps is determined by two things, by voltage and by resistance. It's also compared to the flow of water through a pipe. The voltage is the water pressure. If it's like dripping water or if it's like a fire hose going to take your skin off, there's so much water pressure. Resistance is the diameter of the pipe, how big around it is. In other words, it controls how much water flows through it. The more resistance that you have, the harder it is for the electricity to flow through. Okay, so now we're going to move on to and talk about circuits. Circuits is a closed path through which electrons can flow. So down here's a picture of a circuit. These negative charges right here, here, and here is referred to as, so this symbol right here, electron, is right here. Electric current is the flow of electrons through a circuit. So you have, basically these two things are the same thing. So you have electrons leaving the battery, touching the light bulb, and then they're going back. So you have constant flow of electrons. If you remember way back when we talked about mechanical energy and chemical energy and stuff like that, electricity is mechanical energy because the electrons are moving. If you just look at the battery itself, it's not connected to anything, you have a battery sitting on your table. It is just going to be, at that point in time, chemical energy. And remember we talked about how energy can change forms. When you hook that battery up to wires that are connected to something like a light bulb, your TV remote, or whatever, when electrons start to flow out of it or move, you then have mechanical energy. Electric current works because like charges repel, opposite charges attract. This goes way back to like your magnets. The north poles, if you tried to put two north poles of a magnet together, they would push apart. A north pole and a south pole of a magnet will attract. They will stick together. Okay, so now we're going to talk about different parts of a circuit. First of all, you have to have a voltage source. You have to have a source. Your remote for your TV will not work if you do not have any batteries in it because you do not have a voltage source. voltage source provides the potential mechanical energy. So now remember, potential means that it has the potential to do work. Mechanical energy is the energy of motion, energy of work. So when you hook this battery up into your remote and you start pushing buttons, that is now kinetic mechanical energy because it's kinetic, those electrons are moving, mechanical energy because it's having something do something. Examples of voltage source, you have batteries, power plants, the Hoover Dam, let's see, solar power, the batteries, and when you have solar panels, it stores energy, chemical energy, in batteries off of a solar panel. Okay, so then the next part of a circuit you have is the conductor. Wow, I told you this stuff would come back to haunt you. Conductors are materials that allow electricity to flow through them easily. Okay? In circuits, these are usually the wires. So if you have a tiny wire, if you have the big power lines, okay? So there's your conductor. The receiver. If you're a football fan, it really is like the person catching the ball. Okay, the source would be the person throwing it or kicking it. The ball would be the conductor, and then the receiver is the person catching it. The receiver turns the kinetic mechanical energy of the electrons into another form of energy. So when those electrons have left that battery, they're moving, so you have kinetic, mechanical energy because they're doing work of some sort. And when they get to this light bulb, in order for this light bulb to light up, it has to change mechanical energy into another type of energy. For this, it's going to be a different type of mechanical energy or electromagnetic energy. Examples of receivers, you have light bulbs, you have hair dryers, cell phones. Believe it or not, there is a voltage source in your cell phone known as your battery, and there's all these little itty bitty tiny wires and things like that in your phone. Video games, your TV, anything that you can basically turn on and off is going to be a receiver. Now here is probably, well, they're all very important things. Without any part of this circuit, it's not going to work. Without a voltage source, it won't work. Without conductors, it's not going to work. Without a receiver, it's not going to work. And without a switch, it's not going to work. If the switch on your lights are bad, your lights won't work. No matter if your light bulb's good, the wires are good, the electricity's on or whatever. Okay? The switch is the part of the circuit that opens or closes the circuit, turning it off or on. So this kind of makes sense. If the part of the circuit is a switch, we're talking about light switches. The on-off switch, the power switch. Anything that says on, off, something like that, is going to be the switch. On the computer, when you turn on the power button, that closes a circuit which allows your computer to work. Okay, open and closed electrical circuits. Over here on the right, you'll see some pictures. This particular one is of an open circuit. It is not complete. You'll see this area right here. There's a gap. It's open. That, if you want to think of it as like a door that's open, it's open. It's not self-contained. The electricity will not flow through it. It's going to stop right here. It can't pick up right there. Okay? In a closed circuit, it is going to keep on moving. Okay? So that's why if, let's say, one of the wires goes bad in something, out of the Christmas lights, for example, when let's say one of the wires gets cut, the lights before where the wire got cut would work, the lights after it would not. Okay, so earlier we talked about resistance. Resistance is how easily or difficult it is for the electrons to pass through a circuit. Kind of like an insulator, but resistance, if someone resists doing something, they're usually going to give you a hard time about doing it. The more receivers there are, the harder it's going to be for electrons to pass through. There's more resistance. In other words, there's more places to stop. Okay? The smaller the wire, the harder it is for electrons to pass through. There's more resistance. Think about it. If you have a big open doorway, like all the doors coming out of the gym, and if there was 5 of us in the gym, it wouldn't be any problem getting out of that gym. If you have a door half the size of our classroom door here, and there's 30 of you trying to get out, it's going to be a little bit harder to get out the door. Same concept. The longer the wire is, the more resistance there is. If I told you that tomorrow we're going to go out and run a full marathon, which is 26.2 miles, and told you to go, probably not very many of you would finish. You don't have the stamina to make it. It's kind of the same concept with the wire. The longer the wire is, the more resistance there is, the harder it is for them to go. They can still do it, but it's much harder. The last thing that we have here, this word right here, we've seen before. If you just look at the first part here, schema, we know schema is using your background knowledge. This is schematic. This is a little bit different. Schematic is basically a drawing, like a, it's kind of like a blueprint, okay? Except they're not going to call it a blueprint, they call it a schematic. Schematic symbols are when, like, electrical engineers, my dad, who's a electrician, he draws stuff like this all the time. You're drawing circuits, so they use the schematic drawings to use the symbols to represent different parts. So here's your battery, has this symbol. A wall outlet is going to have this symbol. And the way that I remember this is this kind of looks like the circle that I plug my stuff into. Okay? So here's your wire, and here's a switch. Now remember, a switch is basically like opening and closing a door. Here's what your lamp, incandescent, which would be a light bulb. And then you have the meter, like on the outside of the house. It counts how much electricity is traveling through this system at one time. Okay, so they use these sorts of things to draw symbols to represent different parts. So if you go back, oops, if we go back to here, nope, not that one. Here. If we go back to this one, what you would do with this picture is instead of drawing the shape of a battery here, you would put in that shape that you see. Okay, sorry about that, I pushed the wrong button. So if we're going to draw a schematic here, you would basically take the symbol for the battery, which is kind of that, I don't know, line and plus or minus another line. You would substitute that in for the shape of this battery right here. This picture of the light bulb right here, you would not put that. You would put the schematic for this light bulb. Okay? Then here's your wires, those are right, and then you have your switch here. So this is kind of, this would be a schematic. This is a schematic of a closed circuit. Okay? So that is basically what you guys need to know about electricity. Again, it's nothing more than just how electrons are moved throughout different objects. Okay? Thank you very much.